Hello students, I hope you all are well. So in this video we'll be talking about walk, paths and circuits. I know these terms are very confusing and they look quite similar with each other. So I'll make this video very short video so that you can just understand these terms carefully. Okay, I hope after watching this video these terms will become clear to you. So let's start. First start with walk. So what is a walk? Walk is a sequence, it's a finite sequence whose terms are alternatively vertices and edges. Okay, so walk is nothing, it's just a sequence. Okay, sequence of vertices and edges such that the vertices and edges are in alternate manner. So if we start with vertex, the next term in that sequence will be edge, and then next term will be again a vertex, and then edge, and then vertex, and then edge. Okay, so there will be an alternate manner. As you can see here, A, B, C, D, B here in blue, it's a walk. A, B, C, D, B. This is a walk here. Okay. In a walk, vertex and edge can repeat. Okay, remember this, vertex and edge can repeat in a walk. Okay, and we write sequence of the walk in this form: W equal to V0, E1, V1, E2 and so on. V0 is the initial vertex and Vk is the final vertex. And what is the length of the walk? Length of the walk is the total number of edges covered by it in that walk. Covered by number of edges covered in a walk, that's called length of the edge. Like in this walk from A, B, C, D, B, we have covered 4 edges, so length of this walk is 4. Okay, so walk are of two types. First is open walk and second one is the closed walk. So in an open walk, V0 is not equal to Vk. Okay, initial vertex is not equal to final vertex. For example, here you can see in this graph F, A, B, D, G. This is a open walk. Okay, initial, it's starting from here, it's ending here. Okay, none of the vertex is repeated. Okay, and initial and final vertices are different, so it's an open walk. Okay, so mainly in open walk there's nothing like a closed circle. Okay, there's nothing like a closed thing. Okay, it's open from here, it's open from here. Now what is a closed walk? In closed walk, V0 is always equal to Vk. Okay, like in this graph, the green lines, you can, if you will trace the green lines, C, E, G, F, C, it's a closed walk. It started from C, it ended at C. Okay, so this is a closed walk. Next one, path. Path is defined as open walk with no repeated vertices and edges. Okay, so in path there is no repeated vertex and no repeated edges. Okay, for example, in this graph you can see the orange colored walk is a path. A, B, C, D, E. There is no repeated vertex, there is no repeated edge. So this is a path. As you say, follow this path. Okay, so when you are going through any path, you will not like to repeat any place, or you would not like to repeat any road. Okay, so in path there is no repeated vertex and no repeated edge. Remember this. Now let's just look at this graph. This walk is not path because this vertex is repeating. Okay, if I'll start from here, A, B, C, E, D, again C. So this vertex is repeating, so this walk is not a path. Next is trails. A trail is defined as walk with no repeated edge. In path there is no repeated edge, there is no repeated vertex. But in a trail there is no repeated edge, but vertex can repeat. Okay, So here A, B, C, there is no repeated edge, so this walk is a trail. Now let's just look at this graph. This walk must repeat one edge. If you start from here, B, C, G, H, then again it will repeat H will repeat again, F, D, C. Okay. If you start from here, suppose H, G, F, D, C, B. Now this is left, right? So again it will repeat. So if you follow any path, if you'll follow any walk, then one of the edge will repeat. Okay. So this is not a trail because one edge is repeating. So this is not a trail. In trail there should be no repeated edge. Next is cycle. Okay, cycle is always related with trail, and in trail there is no repeated edge. So cycle is defined as closed trail where no other vertices are repeated apart from the start and end vertex. Okay, like below in this example, B, C, G, F, B. Okay, this is a trail because no edge is repeating and starting vertex is same as the final vertex. So this is example of a cycle. Next is circuit. A circuit is a closed trail. Circuit has no repeated edge but may have repeated vertices. Okay, in trail we don't have repeated edge. Okay, but vertices can repeat. So circuit is related with the trail. So here you can see this walk H, B, C, D, E, F, C, G, H. So this vertex C is repeated but no edge is repeated. So this is a circuit. Okay. So you can summarize everything here in this flow diagram. So what is walk? Walk is a sequence containing vertices and edges. So when in a walk there is no repeated edge and no repeated vertex, then that walk is called path. Okay, and whenever the path is closed, it becomes cycle. Okay, and when there is no repeated edge, then it is trail. Okay, and when the trail is closed, it becomes circuit. From this chart everything will become clear to you. You can take screenshot of this. Okay, I hope you have understood these terms. They'll be using in our next lectures, so remember them. Okay, keep everything in mind, what is walk, what is path, because they'll be used now. Okay, thanks for watching this video. I hope you like it. Stay home and stay safe. Thank you.